All right, so we're going to pick up where we left off the other day. And the other day we were talking about constructors. And so I showed you a basic constructor. And the purpose of a constructor is whenever a method is called, or whenever an object is created, this method is automatically called. So this method matches the name of the class. It's the same name as the class. And so it's always just public because you need to be able to access it. And then the same name as the class. Okay, now you don't have to put like a return type or anything. It doesn't return anything. You don't put void or anything. You just leave that off. So just public and the name of the class. And then you will put parentheses and you will put parameters for that if you need any parameters. So if you don't, you just leave it blank. And this is, if you're going to do that, you automatically get a default constructor. So we're going to talk about this. So if you create a class and it doesn't have a constructor, it's okay. It actually just sets everything at 0 for you. You don't need to have a default constructor unless you add a constructor of your own. Once you add a constructor, you no longer have the default constructor. So we'll talk about how to do that. But mainly the purpose of creating a constructor and not just having the default constructor is because we don't want everything to just be set at 0. So if we have like 10 properties, we don't want them all to be set at 0 because then we have to go to a setter and set all those 10 properties. So it's good, like if you're creating an object, a lot of times you know the property, values of the object when you're creating it. Like if I'm creating a box, hopefully I know the length and width of the box. And then I could just put those in there. And if I don't, I can create it with 0 and add it later. That's fine. If I add that option. But it's it's good to put the values in there because then when the object is created, all the properties are filled in, you're ready to go. So you get to decide as a programmer, are you going to allow them to create an object with, just the default values? Are you going to force them to put values in there? Of course, they could just put 0 for everything, but you're telling them what they have to put in there and basically setting up the object. So the constructor's job is to set up the object. So we're creating an object and we're setting up the properties for it. And again, I know I've had this question in the past, so then what's the purpose of the setter? In that case, the purpose of the setter would be to change it later. So like if you decide later that one of the properties has changed, the purpose of the setter is to modify that. And if you do decide to allow the constructor to not take in all the properties, to skip some, or if someone puts a wrong value or something, the setter allows you to change it. Okay. So when you're doing a constructor, again, you won't see a return type here. You won't even know it's not returning anything. You won't see void. You don't have to put that on there, just public and the name of the class. And so it should start with a capital letter because classes start with a capital letter. And then whatever you need to take in. So if your object is going to have a length and a width property, then you would take in a length and width, and then you could fill those in. And it's the same thing you do in a setter. You're basically just changing the fields to match what's coming in to, set it up. Okay. And then you would put your constructor in your UML as well. And so because it's public, you put a plus sign. The name of it is the same name as the class. And then whatever, you have in there as a parameter. Okay. All right. So I mentioned this and I typically don't do this, but you could say that you have an object and a data type without actually creating the object. So this is saying that I have a box object and it's type rectangle. Just like when you say like you have a number variable and it's type int, that's the same thing as that saying like, hey, I'm going to have a box and it's type rectangle. Okay, great. But you didn't create the box. Okay. So then box equals new rectangle actually creates the box. Now, if you have a reason for doing this, it's great, but like you could just do it in one line instead of doing it in separate lines. But if you have a reason for not wanting to create it at the same time, you can declare it and then create it later. Okay. Now this, again, is passing in the values to set it up for the constructor. So this will probably be the length and the width for the box. Okay. So again, I mentioned this and I'm going to show it to you in my actual rectangle class that I have. But whenever you create a blueprint, you create your class, you create your fields, you create your methods, your setters and your getters. You can decide if you want to put a constructor or not. It's not required. If you don't put it, there's a default one and it sets everything to 0. Okay. But if you do put one with all of your fields or whatever fields you want to put, then you won't get that default constructor anymore. So you have to add it yourself. And adding it yourself is just putting the same name as the constructor again, adding another, constructor called overloading, right? And then just not putting any parameters on there and then just leaving it empty or setting everything to 0 and null. But if you just leave it empty, then it automatically will do that for you. Because everything, when you have an object, if you have fields, the fields automatically get initialized to 0 if they're number fields and null if they're objects. So you don't really have to do that. I know that when we talked about like when we had variables in a main method, we did have to initialize them or Java gets upset. Like if you have an integer variable in a main method and you didn't initialize it, Java wouldn't initialize it for you. But if you have an object that has an integer field, it will get initialized to 0. So you don't have to do that. Kind of nice. Okay. So I talked about that. Again, this is what it looks like. So what would this default constructor, or this also called a no args constructor, look like? And it's called no args because it doesn't have any parameters. And so you're basically just setting everything up. Now, you could choose to set everything at 0. If you're going to set to something default value, like you want to have 1 be the default value, you could do something like that. If you're going to set it to 0, you don't even really have to write it because it automatically sets to 0. Okay. So it just doesn't have any parameters. And then it has a default value here of what you want to set it to. Okay, so I want to take a look and show you the actual full program. Sometimes talking about a slide doesn't quite do it. So I want to go back here to the rectangle program that I have. And so I have this constructor here that takes in a length and a width. Okay, and sets it as the length and width of the actual field. Okay, and then I have a couple different options here. You can see I have actually 3 constructors. Okay, so one here does both the length and width. This one just does the length. Well, what happens to the width? Well, if you decide to use this constructor, and how will you know that you're using this? Well, if you create an object and you only put 1 argument in parentheses, then it'll just match this one. If you put 2, it'll match the one with 2. And if you don't put any, it'll match the one without any. So Java knows based on how many arguments you put and how many parameters it can match with the constructor, okay, which one to use. And so if you do this, though, you might say, well, what will the width be? You don't have a width. It'll just be 0. Like you could put width equals 0, but it automatically does that, so you don't have to do that. If anything equals 0, you don't have to put that unless you want to. Sometimes it's nice to clarify, like I meant to set this as 0. I didn't just forget the width. Like I wanted to, or if you want to default it to something else besides 0, like you want to default it to 1 or something else. But you could see this one, you might say like, what does that do? Well, it sets everything at 0, and you don't have to put length and width equals 0 because it's automatic, but you can if you want to. But you might say like, why would you do that? Well, so here, let me show you. Okay, so back over here where I'm actually creating the rectangle, I'm going to erase some of this because I think it's a little overwhelming. Okay, we're going to move this down and we're just going to focus on this right now. Okay, so here I have a rectangle that's 5 by 15. I'm going to erase that, trying to make it not so overwhelming. Okay, so I have one that's 5 by 15. So I have 2 arguments, right? So if I have 2 arguments and I go over here, it's going to look for a constructor, because whenever you create an object that has the data type rectangle, it automatically matches the constructor. So it's going to look for a constructor with 2 parameters. So it's going to match this one. And that tells it, okay, I'm sending you 5 and 15. So it's going to take 5 and put it in len. Len is going to go in the length. And then it's going to take 15, which goes into W. W goes into the width. Is that okay with everybody? Okay. So what happens if I do, and then if you want to print it off, you can print it. That's what I have below. Just to test it for testing purposes. We talked about the width and the length. And so if you run this, you can make sure that it works. Okay. So ignoring the area and the change that we have down there, because I didn't talk about that yet. We have the length and the width being 5 and 15, right? Okay. I can just get rid of this for now. Okay, so we have the length and width. Everybody good so far? All right, so what if I just wanted to do the length? Well, is that the one I have over here? I just have length, right? So what happens if I just do length? Like if I just do 5? Okay, well, what will happen with the width? Well, it should be 0, right? Because it should default to 0. So see how it defaults to 0, because it'll match the constructor that only has 1. And so this is good if you have, I know I only have 2 properties, but this is good if you have a bunch of properties and some of them you think they might have ready when the object is created and some you might have later, and you want to allow them to just fill those in later. So just fill in the default values, and you can, instead of defaulting at 0, you could default to something else if it makes more sense. Okay. or depending on what you're talking about. Then what if this one, now in the case of this, I probably should go set that width somewhere because now I have it at 0. But what happens if I don't put anything in there? Well, it'll match this one, and this one will set everything at 0. And so it should say 0. But then you don't want to leave it 0 forever. So at some point you need to go use the setter to set it at something so you can see what it is. So if you do want to set it, like let's say I created it, but later I know what it is, and before I print it here, I would just say box.set, right? And then when I know the width or the length, I would put it in here. And I would say, okay, I want to set it at 1. And then I'm going to set the width. But this is a pain. If you knew it, you could have just put it in up there, right? That's why it's extra work, especially if you have like 10 or 20 properties, right? Here, so it's the same thing. But what happens if I don't do this? Like if I take this out, I'm going to take out this one too, actually. And I'm just going to have the one constructor. If I just have this one option that says I have to have 2 parameters, 2 arguments when I do it, then it's going to be upset and it's going to say, no, you can't do that because that's not an option. So you get to decide as a programmer when you're doing it, how do I want this to work? Like maybe I don't want them to create a rectangle that doesn't have any arguments because they're going to have to go set them later. So don't create the rectangle if you don't know what you have for a length and a width. So you have to know what you have for a length and a width in order to create it. And if you think that's good, then don't add that extra default argument, the no-arg constructor that allows you to have nothing. Because if you add that, then you're allowing people to create one that sets it at 0. So if you can avoid that, and that's why it has that, because you may not want that option where people can create an object with no properties. Maybe you think that's bad, right? So you say no. And maybe you decide, I can let them fill in all the properties and I could let them fill in some of the properties, but I'm not going to let them just go without any of the properties. So you decide like what's important, like what options do they have? What do they have to fill in? And then you go with it because it's going to stop you. If you don't put that extra no arg constructor, it's not going to let you go. So you have to decide if you want it or not. Now, if I don't have, so watch this. If I don't have a constructor at all, so see, I don't have one now. It's just my setters and everything. I took them all off. That's kind of neat, right? So if you don't have one, if you don't put one on, then it just goes with the default. So if you don't want to make them fill anything in, then you could just go with the default. But usually it's good to have them do some things because again, then you have to do the setter for everything and that's kind of a pain. I mean, if you only have 2, it's not that bad. But if you had more, it would be nice to do that when you're creating it. It's a little bit easier. So it is nice to have that. Does everybody see the different options? Okay, so if you don't do anything, you get the default. If you add one, you don't get the default anymore. You have to add that yourself if you want it. So that goes away. So they call it a default or a no arg constructor, but it's the same thing. It just means that it's going to automatically initialize everything to 0 or null, and then you have to fill it in later, basically. Okay, so any questions so far? Is everybody good so far? Okay, good. So let's finish talking about some things on here. Okay, so I'm going to talk about this for a second. We talked about this briefly, and I mentioned it because some of you I know had questions on your assignment because you tried to do equal with strings and it didn't work. So whenever you're doing a string, you don't normally do it this way because it's kind of the longhand way, but a string really is an object. And so normally you would have to do it like this in order to create a string. But Java said, like, no, you don't have to. You could just say string name equals and put Michael Long in there. You don't have to say new string. It's a shortcut for doing it. And so you may not realize that it's a string. But if you think about it, that's why the S starts with a capital, because it's actually a class. And so if you go out there to the string class, there's all kinds of things that strings could do. And strings are more complicated. They're not as easy as primitives that you have, like ints and doubles and chars and booleans, because they have multiple characters that you have to go through. So if you want to know if one string is equal to another, it's not like just checking like a value in a memory location. It's going through all of the characters, so it's a little more complicated. So that's why we can't do when we're doing it, and this is what I mentioned the other day, I want to make sure everybody's with me. So if I was trying to compare M1 for like message, hi, to, and this is the shortcut. We've been doing this all along. M2, we don't have to say equals new string. You could just, okay. So if I was trying to compare these 2 strings to see if they're equal, I would not want to do this. because they're not primitives. And what this will do, what equals equal does is it checks the memory location. Okay, now strings are going to be stored in different memory locations. And so well, sometimes you look out, we'll talk about like the string pool later, how you can look out, but most of the time they're not stored in the same memory location. And if they're not stored in the same memory location, it's going to say false, even though the actual contents can be the same, because it's just checking the location, not the content. So whenever you do equal equal, it's checking the location. And so we need to do this. And so that will check the contents. And so that's why on your one assignment, if you were trying to like make the loop stop when the user typed in yes, if you did equal equal, it may not have worked for you. But if you did a char and you did equal equal, it worked. Like if you did y instead of yes. But the difference is strings are more complicated. So like when yes is more complicated than y. That makes sense. So strings are objects, and that's why we do that. So we've been working with strings the whole time. And I know we don't have that problem in C++, but something to think about in Java. And this is the shortcut way that we do it, but the longhand way is really what we're doing. Okay, now we can pass objects into methods as well. And I don't know if we pass the string into any method, but you can, right? Usually we pass numbers because we're doing calculations. But we can pass strings in their objects. And, just like we could pass strings, we could pass like the rectangle object into a method if we wanted to. So just like when you pass in an int or a double, and you say like int n1, double n2, you would just put the data type. And the data type for an object is just the class name that it came from. So like rectangle, you would just put rectangle. Instead of like int or double, you put rectangle. And same thing with string, like string is the class that it came from. And then whatever name you want to give it, just like you name all your other variables, naming an object is the same. Okay? So if you wanted to pass in a rectangle to a method, it would just be rectangle and then a name like rect1 or something like that, whatever you want for your name. Okay? And then the nice thing about it is it actually sends a memory location. So everything that goes with that object is also connected with like any field that you have for that object also comes with the object. So you have access to all those fields. So it knows everything that there is to know about the object when it comes into the method. Okay, we talked about this overloading. Hopefully this makes sense to everyone. I mentioned the other day when we were in the methods chapter, we took a look at the show input dialog and the show message dialog, and we saw that there were many different ways to write it. And we talked about like how you can set up a value that pops up in the box that's like a default value that you can like type your own number, or you can leave it if you want. And that way, if someone forgets, they don't crash the program. Also, we could change like the icon and the title bar. All those different options that you have that Java wrote for you was called overloading. So it's the same method name, but the way that it knows which one to use is based on how many arguments and what type of arguments you supply. So it looks at the parameters and it looks at how many first. And if it's the same number, then it looks at the data types of what you're doing and it matches. Okay, and it's called binding. It binds the right one and then it does that one. Okay, so same thing with the constructor. When we talked about the constructor, when you create the object, if you give it data in parentheses, it's going to look at the data you're giving it. So you gave it one argument. Do you have a constructor with one argument? If you don't, it's not going to compile. If you do, then you're good. So if you have multiple and you have one with 2 and one with 1, how does it know? Well, if you gave it 1, it matches 1 with 1. If you gave it 2, it matches 1 with 2. Is everybody good with this? Okay. So this is an example. This one actually has 2. Both of them have 2 parameters. So how does it know which one to use? Well, if you use this method, if you call this method add, and you give it strings, it's going to match the one with strings. So it looks at the data type then if the number of arguments are the same. And then if you use an int, it's going to match the one with int. Okay. All right, so we talked about this. So it just binds the right one based on the data types, or based on how many you have. Same thing. Constructor, one has 0, one has 2. How does it know? Based on how many you have. Okay. Is everybody okay with this? All right, and we kind of went through this example. Here's another example, a bank account example. This is the UML diagram. So this is COSC. It only has one field. It has a balance, which is the double. Monetary amounts, you always want to make double. And then your field should be private, unless you have a reason for making it public. It has 3 constructors. See how they all match the same name as the COSC? This one is an empty one, which means that you could create a bank account without having a balance. This one, you could create one with having a balance that's a decimal number. In this one, you could create one that has a string, and it'll probably just take and convert the string to a double. Like if you added it as a string, it'll make it a double. Okay. Then there's two different ways to deposit. You can put in a string number or you can put in a double. If you put in a string, it matches the string and double. Again, probably just because if you put in a string, it'll convert it to a double for you. And it's just trying to show you, I think, overloading. So I try to come up with, this is your book example, an example of where you would want to have the method twice. And so everyone just has a string and a double. Okay, has everybody got that? So it knows based on whether you put string or double, which one to use. And the string just converts it. All right. Whenever you create fields for a class, they can be used in any method in that class. So, and this should make sense. So when we create, like what it's saying basically is, this is the scope. So when we are looking at this rectangle class, these fields that I have here, I know that they're private, but they're still good for this class. Like private just means another class, but it's okay for this class. And so any of these methods that we're using, like you can see, we're actually using it here. It's good for those. It knows about those fields because it's in that class. And now in another class, it won't, but in this class, we're good. All of them. Everybody good? Okay. Shadowing is what I was actually just about to show you. We talked about this briefly. Whenever you're naming things, just be careful. And I think it's best just to show you. I talked about it the other day, but let me just show you. So here, again, you have this len parameter, and you have a length variable. But if you make this length, then it gets confused because it doesn't know whether you're talking about this one or you're talking about this one. And see, it even kind of highlights it and tells you it's assigning it to itself. So what does that mean? Well, it automatically defaults inside the method to the actual parameter, not to the field, because, you know, the parameter is the closest thing that it has with the length. So it just assumes, oh, you want to work with the parameter. So what it's saying is take in the length and set that length that came in as the length. And it's like, that doesn't do anything. That's what's telling you. It's like, oh, you're putting the parameter as the parameter, so it's not doing anything. The reason why it's not setting the field is because it doesn't know, you know, how to do that, because they have the same name. So how do you refer? If you really wanted to do this, how would you do it? You would actually put, if you want to refer to the field, you have to put this dot length. And this tells you like what object you're working with. And in this case, this would be like the active object that you called the method on. So whenever you call set length, what object did you call it on? This is that active object. So like if you say box dot set length, box is like the active object. So which length are you talking about? You're talking about box's length. So like this means like box's length. Okay. Now it doesn't always have to be box. It could be whatever object whatever object you call the method on. So that's why we can't say like an actual, you'll always notice in a class, we don't refer to actual objects in the class because every time you do it, it'll be different names and it won't be the same object. It has to be generic. And so that's why the word this is generic. It means like whatever object you're currently using. So when you want to refer to the object, it's this. And so this dot length means like the object's field, like the object's length, not the parameter that we're talking about. So that's how you differentiate between parameter and field. But it's kind of a pain because if you forget to put this on there, then your program doesn't work, right? So I would just recommend giving them different names. If you want to do that, you can, but you don't have to use the word this if you just give them different names. Now you can if you want to, but you don't have to. Like it's assumed, like if they have different names, it's automatically assumed that you're talking about the field because there is no other length. So it's not confused. It's like, oh, the field. But if you have the same name, it's like, what? Which one, right? Does that make sense to everybody? Okay, so that's called shadowing. And most people try to give them different names, but you will see some people say this, so it's good to know, like, what does this do? And so you might see people put this even though they don't need to. But this represents the object's field in that particular example. All right. Now, we talked about imports. Hopefully when I showed you the API and everything, you were able to kind of see how you can search for the package and then you could find the class, and it hopefully helped you understand the imports better. Like, why do you need the import? It tells it where the package is and the class is. And I know you might not have the packages memorized, and that's why I let you use references when you're working on, you know, your assignments and your checkpoints and everything. But as you start to use them, you really start to kind of learn them, and they're not that hard. But like scanner is Java util, that's the package that belongs to. And all that's saying is that you have the scanner file, the scanner COSC, and it is part of the Java util package, which means it's in a folder called Java and a folder called util, and that file is located in there. Now, if you wanted to, you could actually stop at the util and put an asterisk here. I don't recommend it unless you have multiple with the same package. Now, so let's say we're using Java util for something else, and you were saying Java util this class, Java util this class. Okay, then you could just do Java util period and put an asterisk, and that stands for wildcard. If you ever used it before in any like queries or anything you're ever doing, if you do wildcard, it stands for like anything after that, doesn't matter like what it is. And so what it does is it allows you to import anything from the Java util package without having to put separate lines for each one. And no, you can't put import asterisk and just do everything. Always have students ask me that. You have to take it to the folder that it's located in. And it also won't go inside like another folder inside that folder. Like it has to be in that direct folder. It can't be like a folder back or a folder this way. So you have to do direct. But I don't recommend doing it unless you have multiple. Like I wouldn't do it for scanner. Because I think, and it's everybody's programming preference, but I think when you're looking at the imports, it kind of tells you what you're going to use. And I like to see that scanners there. Like I like, if you do that, I don't know what you're using from there, you know? So I kind of like to see, but I could see if you're doing like 3 and you don't want to put it, you could shortcut it. Now, you don't ever have to put Java lang. You could, but you don't have to because it's automatic, like the default. Okay, so just a kind of brief introduction to some of the basic standard packages that you have. We use the text. Java text does the formatting. That's where I get the decimal formatter. And we use Java util for the scanner. We have not used the other one except for Java lang. Java lang has the integer, the double, and the system, but none of the other ones. Okay. And then just like you are hopefully doing pseudocode whenever you're starting your coding, and it might just be jotting down some things like what's your input, what's your calculation, what's your output, and what needs to be repeated, and what decisions do I have to make. And this can be really whatever way you want. It's just a thinking process about how you're going to do the program before you actually code it. You also should think about, you know, when we're doing object-oriented, we do a UML diagram to kind of lay out like what getters and setters are we going to have, what constructors should we have, and that kind of lets people know, like without looking at what's going on, without actually looking at the code. You should also think about like what other classes you have and how they interact with each other, and you know what properties are you going to need to be able to do that. Not every property you have for every object is important, right? I mean, it just depends on what you're doing. And when you have an object being used in one program versus another, like maybe it's important in this one, but not important in this one. You know, like when we're doing someone's bank account, the person's hair color doesn't matter, right? Like we just don't need that information. So don't add information that's not necessary. Okay. All right. So is everybody following pretty good so far? I know it's kind of new for everyone, and so that's why I tried to go a little slow when we're going through it. But does this rectangle one make sense? So y'all, I'm going to show you a bunch of other examples too, but is everybody okay with the rectangle example? Okay, good. Well, that's a good start. Okay, so what I want to do is I want to show you another example if everyone's okay with this. I don't remember what I did. I think I deleted something, so I'm going to not save that. I'm going to bring up this other one that I have a UML diagram for. It's called the cell phone. Okay. Okay. Now, the cost of a cell phone, there's 3 fields: manufacturer, model, and retail price. They're all private because, again, unless you have a reason to make them public, they should be private. With the data types, the manufacturer and the model will be strings, and then the price, of course, will be a double. We'll have a constructor that sets all 3 of those. And then we have setters for each one of those fields, and we have getters for each field. And you notice that the setters are all going to be void. The getters are going to return, and they're going to make sure your return types are the same as what you have up here for the fields. And then these are all public because you need to be able to access them. Notice that your getters don't have any data in parentheses, but your setters do because you're actually changing something, so you need to have the value to be able to change. Is everybody following that? Okay, yeah. All right, so let's take a look at the actual code and see how that equates in code. I have this here. And unfortunately, I actually have them switched, so it actually should be phone, not cell phone for the actual class. Sorry about that. I do need to fix that. Okay. Now, and that's one thing before I forget. that I want to warn you about. Whenever you start a NetBeans project, here, let me just do it real quick so you can see. Two things. Whenever you start a NetBeans project, and let's just call this person. Now, when you're thinking about it, let's say you're going to have a person class. Okay. Now, you don't have to do this. I'm going to delete this in a second. I just want to show you something. Let's say you're going to have a person class. So you're like, I'm going to name my project person. Okay. So one of the problems with this, I want to show you something. First of all, I don't care about that package anymore. If you want to leave that or you want to delete it, it's up to you. Period. And what's before it. You could delete it or you could leave it. So I'll show you. All that's going to do is add this extra package in here. But what happens is maybe I'm thinking like, okay, I'm going to have this person class. I'm going to create a person object. So I'm going to add my fields and I'm going to add my setters and gatherers. But then I get in there and I'm like, oh man, now my main's in here. Like my main's not supposed to be in here. It was going to be in my other file. So now I have to give the other file a different name because I already named this one person, and it just creates all kind of issues. So normally what you do is like, let's say you wanted to name your class person. You can call the other file like client or something like that, or something to get like person client, or the name with something else after it. Because if you use your good class name for the one with main, then you'll have to give the other one a name. And it's really important that the blueprint one be the good name. Okay, because that's the one that you will give and share with everybody. And so you don't want to call like your person class P, because everyone's like, what does that P file, Java file do again? Like, what is that blueprint? We want it to be really descriptive about like what it is, so that nobody questions like, oh, this is a computer object or this is a person object. Like, we don't want to call it something that people would be like, what is that? Okay, so try not to, when you're calling, I guess my point is, try not when you're calling your project to give your good name to the one with main, like to your actual main class. Give it something else. Maybe just put the word client before or after it. And then you could give your good name to the other class. Because when you do it, you're going to click file, add a class, and that's where you're going to give your good name. That makes sense. But this happens a lot. Students will then give like a random name to the other one, but that's really the important one. Like the other one's the important one. This one isn't as important, because this one is more like a testing. You could call it test too, like testing class or something. This is where I test it. But the other one is the one that I'm going to give to people. That's the one that I'm going to use. This is where I just create the objects and I test my different methods that I have to make sure that they're working. But the other one is the blueprint is the one that I want to share. And so that's the one I want to have the good name. Does that make sense to everybody? Okay, so just be careful with that because that happens a lot. Okay, and that kind of happened with this because now I have cell phone over here and I have phone over here, and that's why I was mentioning that. So we have the fields, they're all private. Again, it's very important to make them private, and I will show you in this why that is, okay? Now, I told you that we have one constructor that has the 3 fields being set here. Okay, everyone okay with that? Okay, and you notice that all the methods have this documentation, and as I told you before, it's really easy once you create the method to just do / asterisk and enter, and it actually fills in all your parameters and return type, and all you have to do is put in the descriptions. So it's actually much easier to do after you're done with your method than before, because otherwise you have to put all those tags in. So the setters are void, and they have the data type, make sure it matches your field. There's really not a whole lot you could do with like model and manufacturer. I mean, you could have a list of valid ones if you want, but there's not a lot of validation you could do with that other than a list. But price, we could definitely do. We don't want negative prices in there for our phone. So I definitely want to come back to that and validate that. The getters are just simply returning whatever data type the fields are. And you have to use the field name. This has to match what you have at the top. So this has to match what's up here. Does that make sense to everybody? Is everybody kind of getting the idea of this? Am I going too fast or too slow? Okay. All right. So everybody's okay so far, right? All right, good. So if I go here, no, I don't want any of this actually, because I think this is too much. I'm going to start from scratch. Okay. So here I have this constructor, right? And the name of my class is phone, right? So when I create a phone object, I'm going to have to say phone. So that's the first thing I'm going to do, because I can't use setters and getters for the phone until I have a phone, right? And you notice that is one thing that I forgot to mention. And I mentioned it the other day, but I can't have static on these because they require an object to do them. So you'll notice that none of them say static. Okay. And that means that I have to have an object in order to do it. So like I can't set the price of the phone if I don't have a phone. So first I need to create a phone. So how do I do that? Well, I say phone because phone is the name of the class that I created the blueprint from. So phone, and then I have to give my phone a name. I call it P1 for phone 1. I'm so creative. Okay. Equals new. Phone is the name of the class again. Now, if I try to do just the empty phone, it's going to tell me I can't do that because that's not an option over here. There's a constructor that has 3 parameters, and so I can't just have 0. Okay. Now, again, you might say, well, where's that default argument? It doesn't, the default constructor, it doesn't come whenever you add one, so I don't have that. So if I want the ability to do that, I have to add the no arg constructor if I think that's a good thing. But maybe I don't think that's a good thing. Maybe I want you to fill in the values. Okay. So that means I have to add a manufacturer, model, and a price in order to create a phone. So I have to go here and we'll say like Google Pixel, no, a lot. Okay. And now it's okay with it. It's like, okay, I got it. So now I have an object that has those 3, values for the fields. Is everybody good with that? Good. Okay. Now, if I go back over here, I can ask it anything like get manufacturer, get model. Okay. So I could do like a system out print line, and I can print like all the information about it. I could put a label with it if you want to, but it's Google. I think it's going to be pretty self-explanatory. So we'll just do the name of the phone. So P1 dot get. Now what's really cool again is it pops up like, which one would you like to get? I'll get the manufacturer. Okay. And then I have to decide, like, do I want an empty line or how do I want to display it? Maybe I want to put it on a separate line. So we'll do like \n here. And then we'll do like the P1 again, because we have to work with phone 1. That's the only one we have, right? Has everybody got what I'm doing here? Okay. I just don't like it all on one line. So I'm trying to put it on separate lines. P1 dot get the, where's the price here? And I could take this to the next. And automatically it gets indented because it's continuing on the next line, and that's good. I like that. So I'm gonna leave that. Okay, now if I run this, and I don't need this anymore because that was before. Okay. Then this is going to hopefully just print the information back out for me. And hopefully you know what that is. I mean, you could put a label with each one, but I think it's pretty self-explanatory that that's probably the price and the manufacturer and the model. Okay, so that's just testing to make sure it works. I created an object, I filled in the data, and then I just use the getters to make sure it's working. Now, again, you might say, what's that purpose of the getter again? If I wanted to change something. So let's say I want to change the price and I'm having a sale. How do I change the phone price? Well, when I first gave the phone, it was 800, but now it's on sale. And so I'm going to use the set retail price, and it's now 600. Okay, Black Friday special. Okay, then I'm going to print again. And it's going to change, right? Okay, so if I didn't have that setter, I couldn't change it because I can't change the field because it's private. So if I try to change the field, it's going to yell at me. So let's try it. Like normally I would be able to do this. I would just say the name of the field, which is, let me look. Make sure I get it right. Retail price. I should just maybe just call it price. And I would just put equals. It's going to say, no, you can't do that because that's private. Okay. Okay, I'll use the setter. No, why can't I do that? Well, right now I don't have any validation, so it really doesn't matter. Like if you don't have validation, it doesn't really matter if you directly access it because the setter's not doing anything different than if you directly access it anyways. But if I did want to add some validation, and so let me make this public. Actually, no, let me change the validation. So let's go to set retail price. Let's say we want to make sure that it's not a negative number. Like the phone could be free and it could be 0. So we'll leave that. I mean, that would be great, right? But we don't want it to be negative. So we'll say if whatever we have here as our parameter, we're checking that if price is greater than 0, then we're going to go ahead and set it. Now I don't really need to do, I could do 0 if you want, but I don't really need to because it's already 0. So, I mean, unless you like had it as something else, you want to change it to 0, then I guess you want to include 0 in there. But it's going to set at 0 anyway, so. Or, so you have a couple options here. You can decide how you want to do this. So this is only going to set the price if it's greater than 0 or 0, okay? But what happens if it's not? Well, if I have an else in there and I set it at 0, then it'll be set at 0. But if I don't have an else, it'll just stay whatever it was before. So you have to decide if that's what you want. Like if it used to be 600 and someone puts a negative number, maybe you want to leave it 600 or you want to leave it 800. If you set it 0, now you're giving it for free. So it's really up to you. Do you want to leave it at what was a valid price that you had before, which may have been 0 because maybe when they created it, they put 0, or you had a default constructor that set it at 0. You really have to decide, do you want an else that sets it at 0, or do you just want to leave it what it was before? So it's really up to you. I'm going to leave it what it was before, but you could put an else that sets it, and it doesn't have to be 0. It doesn't always have to be 0. Maybe you make your default for your phones $200, and we default to 200. If you don't know what the price is, it's 200, right? It's a deal. So you decide, but that's what the else does. The else will override what it was before and set it at a new price. So if you're saying set it, and you only have the if, and the if doesn't match, just know that it'll stay whatever it was before. If you add the else, you could put a default in there. And I'm not saying one way is right or wrong. It just depends on your scenario. Does that make sense to everybody? Okay, so I kind of like it staying what it was before. So I'm going to leave that. Okay. And what I'm going to do, I'm going to go back here because I can't do what I was trying to do this way because that's private. We'll talk about that in a second. So we'll say set retail price. And what I'm going to do is I'm going to make this a negative number because that's a problem, right? Notice how it was 800, and then I put that negative 600 in there, but it didn't change. It's still 800. So this is what I was talking about before. I put an invalid value in there because I validated it now. I don't want to give people money with phones. So I need to make sure that we're not actually giving people phones and giving them money for it. So I don't let that value get in there, and I just keep it what it was before. But the else would have overrode that and put like 0 or 100 or 200, but I just left it so it stayed at what it was before. Does that make sense to everybody? Okay, so that's one way to stop that from happening. Now, if you open this up and make this public, okay, so I take off the private there on retail price. Now I can do what I was trying to do before, and I could get bad data in there. Now I got bad data in there. How do you validate that? You can't. You can't validate that because that's a field, okay? So you have to have a method that can do that, and they have to go through a method. If they're skipping directly to the field, there's no way to validate that on the class end, right? So that's why we don't like to have fields be accessible if we think there's going to be validation, because that allows people to skip the validation. Like you could say, oh, use the setter, please. Well, I mean, but I don't have to because I'm able to just skip. So you don't want invalid data in there. So if you think you're going to have validation of some sort, like maybe I come back later and I do have a list of manufacturers. So I want you to go through the setter and it has to be one of the valid manufacturers. And I have the manufacturer variable be public, then people just skip and they misspell, Google, and now we have a misspelling in there. And then when we search for Google, it doesn't come up because somebody misspelled it in the system. And so that phone's left off. And now does it get changed with all the prices and everything else? Does that make sense to everybody? So it's very important not to let people, unless you have a reason again for making the field public, and maybe you do, it's better to just leave it private because you never know, somewhere along the line, we might come back and add validation or add. So there's really no reason why well, there are reasons, I shouldn't say no, for making it public, but unless you have a good reason, you really shouldn't let things accessible like that. Does that make sense to everybody? Okay. So I don't want to leave that open. That's why it's important to write the word private on there. Now, I want to bring up another concern. You notice here that nothing checks the price here. So when I was here and I added it here, oops, no, I don't have it here because I took that other one off. When I did the setter here, it did the validation because the setter does the validation. So the setter down here validates, but up there it doesn't validate. So if I put a negative number here, is it going to be negative 800? Yeah, because there's nothing there saying it can't be, right? So it's going to get negative 800 in there, unfortunately. And it's going to stay negative 800 because it's not going to change it to negative 600 because that's wrong. And we know that's wrong through the setter. But we didn't know that was wrong because nothing in the constructor said that was wrong. So you don't need to, or you need to add it to the setter, but you also need to worry about the constructor having invalid data. So you could do a couple things. You could just like go down here and say, oh, I already have this logic. I'll just copy that up there. That's fine. You do that. But we know that sometimes when we do that and we go and make a change, we might forget to change one of them. Like let's say, oh, I want to make it greater than 0, not greater than equal to 0, or I want to change it and I forget to change one of them. Now I have, different ones and different validation for each one. So that's the problem with like copy and pasting things. You usually want to ask yourself, is there a better way? And this works again, but you already have a setter. So can we just call the setter that we already have so that if we change it in the setter, it changes here? I think that's a little more efficient. Now Java has a slight problem with it, but that's okay. Talk about that in a second, but let's call set retail price and let's pass in the price. And then that way the setter handles it, not the constructor. Now, what that'll do is it'll pass the price here. It can have the same name, by the way. I know some people question, like, can I have the same name here as a parameter as down there? Yeah, the parameter names could be the same. That's okay. It's the field and the parameter that I don't want the same. So the parameter could be the same. Like, it's just going to take the value from here and send it to here. So it's okay to have the same name. And then this is going to validate it. Now, why is it upset with me? Well, it's something we haven't talked about yet. It talks about being overridable, which we haven't talked about yet. That's going to come in chapter 10, I believe. We're going to talk about like overriding. We don't have a subclass to worry about overriding right now. It doesn't like that you're using an overridable method in a constructor. And I don't have a class that's going to override it. So I'm okay with that right now. But really what it wants you to do is it wants you to go down there and make that method final so it can't actually be overridden. That's what it's saying is I don't like it that this method could be overridden. We haven't talked about overriding, so I'm not concerned. I'm just sometimes when NetBeans make suggestions, you can ignore them, especially for now, because we haven't gotten that far. It's just a suggestion. You don't have to do it. It's just saying like, hey, this could create problems in the future because like you could override this and it could cause problems. But I'm like, no, I can't because I don't have another class right now.
Do you make suggestions on switch cases? I noticed that.
Yeah, it does. Yeah. And you could do it or you could ignore it. Like they use the new arrows and it might do that. Or like sometimes if you do and if else it'll say it's redundant and it'll switch it for you. And you could switch it and say like, this looks great. I'm going to use that. Or you could like say like, nah, I don't like that and go back. Like you could say like, no, I like the way I did it. You don't have to ever like go with it. Like it's just an option. It's like saying, hey, would you like to do this? And you're like, no, I would not like to. But if it's red, you got to fix it. Yellow, it's just like, hey, maybe you want to do this. Like, no, I don't. I'm going to leave that. But what it's saying, like if you wanted it to go away, and we'll talk about this more and we'll come back to this when we get to chapter 10. What it's saying is it wants you to put the word final on here. And then it's happy. Oh, actually, I have to move that word before. It wants that to be final. And we haven't talked about final yet. We just talked about finals with variables. So we haven't talked about making a method final. And the reason is because making a method final goes with overriding. And we haven't talked about that. So not worried about that. But that's what it's saying. And again, you could just completely ignore the suggestion and say, nope, I'm not going to do that. And that's fine. Because I don't expect you to understand the final. Okay, so you could also just copy and paste the validation up there, and that's fine too. But I just think like you already did it, so why don't I do it again? But that'll stop me. Now, what do you think this will be now? Now that I stopped it, I tried to put negative 800 and negative 600. What do you think the price will be when it prints? What does Java default to?
The amount that you set for like the validation.
So I didn't give it like an else.
Oh,
So there is no else. So Java's only thing is whatever it's initialized to. What does it automatically initialize to? Do you know?
0.
0. Yeah. Oh, it will do null for objects. 0 for numbers. Yeah, because there's no else. If there was an else, yeah, it would totally do whatever the else said to do. But because there's no else, it'll just go with what it has for initialization. And It doesn't have anything to set this as because it goes down here and it doesn't match. So it's like, set it to 0. Like, so it'll put 0 there. Okay. And again, you can put the else on there to default it to something else if you want to. And then that way it wouldn't do 0. It would do whatever you asked it to do. But I kind of liked it to go back to, but it's up to you, whatever you think is good. Okay. And that's why I think it's nice, because I might change my mind later. I think it's nice to have the validation in here and have it actually connected to there, because if I do go change this to have an else, I might again forget to go up there and change it up there. And I want it to be consistent. And so that's why whatever I decide to change here, I don't like to change it in a bunch of places. So it's kind of nice that it tells it to go there and do it. Okay. Is this making sense to everybody? What's going on? And you have lots of decisions to make when you do it. Like, what scenario is this? And do you want to add an else? And do you do you want to have extra constructors? Like, do you want, so when I'm looking at this and I'm creating a phone, maybe I don't have a price yet. Maybe I want to just create the phone and I don't want to put a price in there. So maybe I want to default the price to something. So how can I do that? Well, technically, I guess I could just put 0 in there. I could just put the default price in there. But maybe I want all the phones to be consistent and I don't want people entering default prices because they might make a mistake, right? So maybe I want to add a constructor that has the option to just do the manufacturer model. So when I'm doing it, just copy all this. Okay. And this would do, what did I do? I did it right. Okay. Now, this one is going to get rid of price. Now you could either just leave it, which will be 0. It'd probably be bad to have free phones though. So you could do your own price. Actually, it's not price, it's retail price, right? Keep forgetting. It's this one, the field retail price. And so you can make your own price, like maybe all phones are defaulted to 500. Okay. So if you create a phone that just has a manufacturer and a model, instead of initializing it at 0, you just put whatever number you want in there. If you don't put the field in there with the number, it's going to do 0. But if you want a different number other than 0, you could just default it in here. And then allows someone to create it with just the manufacturer and the model, and it gets the 500 price. Now, what could they do later? They could just come say the name of the phone dot set retail price and put a different price in there and change it. But maybe when they're creating it, they don't know yet. Maybe it's just like a general phone, it's 500, right? If we want to change it later, we could come change it later. But that allows people the options to do that. And I don't know if you would create a phone without a manufacturer model, but if you want to create a phone that doesn't have a manufacturer model or a price, you would add an empty constructor. But I don't really like adding empty constructors because I don't think you should create objects that don't have any data. But you can if you want to, and then you just have to fill it in later. But you don't want to forget because everything is null and 0 if you don't. But you have different options with like 1 parameter, 2, 3, and have defaults for them. Is everybody with me? So how would that work over here? Well, if I did decide like, hey, I don't know yet what that's going to cost. I'll just leave it at 500. When I print it, it's going to say 500, even though I didn't put a value here, because that's the default, right? So it just uses the default. And then later, if I decide I know what it is, then I just add that. I just say, okay, P1, because P1's the phone, dot set retail price. And then I put whatever it is in there. So maybe it's 700. I put that value in there. Everybody okay with that? All right, so pretty good. All right, I want to show you another program that I have. This one I don't have a UML for, I don't think. Actually, I think I have it open over here. It's pretty basic. So think I have it. Okay. So if you look at it, this one has, it's a temperature program. I know we talked about like Fahrenheit and Celsius before, but this one does an object. And so just to kind of, you can think of it in like object terms, it's a temperature object and it has one field, it has the Fahrenheit. Okay. Now, what does it do? Whenever you create the temperature object, you can pass in the Fahrenheit, which the parameter name is F, and it just sets that. Again, try not to do shadowing where you give them the same name. Okay. A setter where you could change the Fahrenheit if you want. So you could change the temperature object Fahrenheit to be something else with the setter. So when you create it, you can establish 1 Fahrenheit, but you could change it. And then you could return it. And then you can also figure out the Celsius. And, you know, I usually like to make them action words, but because Celsius usually like represents a variable, not a method, but that's fine. You could make it like get Celsius, kind of like that better, maybe, or calculate Celsius. I'm going to change that. This is bothering me. I like it to be an action. Okay. So get Celsius is going to take whatever your Fahrenheit is. Now your Fahrenheit is the field that you have up here. Okay. And so it's going to calculate that. And we talked about this equation. Hopefully that's okay with everyone. The reason for the 5.0, although you don't have to have 9.0, just 5.0, is to make that a decimal when you do division and not integer division. Because otherwise this 5 divided by 9 would give you 0. And so to fix that, only one of them needs to be a decimal. And then this doesn't need to be a decimal. Doesn't do anything, but okay. And then same thing here. This would be get Kelvin or calculate Kelvin. One of them needs to be a decimal for it to be a decimal for the division. And then this, you don't necessarily need to have that. But that's the calculation for Kelvin. Okay, everybody okay? Now, you might say, don't I need to pass in the Fahrenheit? Like, how can I calculate the Fahrenheit if I didn't pass it in? It's a little different and it's kind of hard to get used to, but if you're talking about an object and the field for the object is the Fahrenheit, then if you already have the object, if you're taking the object and you're asking it to get Kelvin, then it already has the Fahrenheit because it's part of the object. So it's like accessible to you. So you're not passing it in. And you wouldn't want to pass it in because the user might not know the temperature of the object. You're saying that that temperature belongs with the object, and so it can automatically get that temperature. Okay, does that kind of make sense to everybody? So make sure you're not passing it in because that Fahrenheit is just the field that the object has. Up here is where that, so it goes with the object. So in order to calculate like Kelvin or Celsius, I would need to have an object first, and then I could do that. Okay, so over here, there's a lot of extra things in here. Hopefully this isn't overwhelming. I could leave it this time though. We already know this, so I'm not gonna have all this. I try to slim it down a little bit, so it's not so expanded. Okay, so this part is just asking the user for Fahrenheit. And then this part here, hopefully this isn't too confusing, is going to take it in, like it's going to be command line. So it's going to say, enter the Fahrenheit temperature, okay? And that's going to have the blinking little cursor. Well, that, whatever you type, is going to go into what I have highlighted there. And then that is going to create the temperature object called temperature, although I should probably name it something else. So it's not the same name as the class. It has different capitalization though. So the object one is the lowercase t and the class one is the capital T, but you can maybe not give them the same name if that's confusing. And then it's going to have, whenever we do it, and I change the names, whenever we do it down here, we would say get Celsius and get Kelvin. And again, we don't need to pass in the Fahrenheit because that's coming in right here. So let me run it so you can see. So enter the Fahrenheit temperature, 45. It's going to calculate Celsius and Kelvin for me. So notice how I'm not passing in the temperature here for the method. I'm passing in here for the object. Okay, so this is the object. And we could name it differently if you don't like to have the same name. Just make sure whatever you name it, you use down here as well. So this is the class name. That's where you created the blueprint. Okay. Then temp is the object name here. And that starts with a lowercase letter. And then you say new temperature. That actually creates the object. So this is just establishing what data type the object is. And this is actually creating it. Then you need to have here for the constructor, you need to have an argument that comes in for F. And the argument that comes in from F is actually taken from the keyboard from you typing whatever it is. And so I could just put a number there, but instead they took it through the scanner for this example, just so you can see. Okay. And once you have that Fahrenheit, that goes with the object. So like temp has that Fahrenheit. Now, how do you change that Fahrenheit? That's the purpose of the setter. Okay. So if you don't change if you don't do the setter, then that field is private. So there's no way to change it. So you have to use the setter because if you keep calculating things, it'll just be the same Fahrenheit over and over again. How would you change it? You would just use the setter to do that. Okay. So if I do this down here, if I want to change it, I would just say temp dot set, and there's a set Fahrenheit, and then would change it to whatever I want. Now I could do like another enter Fahrenheit, and then I could use like the next double again, or I could just put a value in here. Except that value will always be the same, right? Because I'm not able every time I run it to change a new one. But and then what I would do is I would display this again afterwards, and I would get new answers, right? Okay. So this one is taken from the keyboard, so it can be whatever I want it to be from the keyboard. So 98 would be the first one. This would be the one with 98, and then this one would be the one with 32. Now, could I just do this again? I could just do the scanner again if I wanted to. And I would just do this again and use that scanner here. And then that way I could do, and then I could try 32 here again, or, 31. Okay. Does that make sense to everybody? And you're probably saying like, why would I create a temperature object to do all this when I could have just calculated it, right? With that simple equation without having an object? Yes, totally. But I'm just trying to get you to see multiple examples of different things that hopefully you can relate to. And I know that this one probably is much easier just as an equation without having an object. But I want you to see the difference between like when I don't have an object and I do have one, like if I'm calculating Fahrenheit or Celsius the other way, I had a static method, right? That just did the calculation and sent the answer back. Or maybe I didn't even have a method at all. I just had the calculation and the main method, and I just printed the answer, right? So depending on what you're trying to do, I mean, the easiest thing to do would be just have the scanner ask for the data, and then right in the printout do the calculation with whatever data. That would be like the shortest program ever, right? But if I wanted a method that I was going to reuse, then I would have to write it separately. I have to then take that calculation and put it as a separate method, and then I have to call that method, and I have to send back the data. I know it sounds like a lot of work, and you're like, why, when I just put the calculation right in the main method, like, why am I separating this? Think about reusability. I know some of the things that we do, you're like, this seems easier when I just put the calculation right in there. Like, why do I have this object, or why did I create this separate method? It's kind of just a process because we're trying to get more advanced programs. And sometimes you just can't do everything in the main method. Like you can't do everything you want to do by putting all your calculations in the main method because they're not reusable. Nobody can share anything with each other, and you can't get to complexity without like the stepping stones. And so bear with me that I know that some of it seems like ridiculous, and you're like, I could have done this. I've been there. I thought the same thing. Like when I was back and I first started, I was just like, that doesn't seem like putting this calculation in this other method is like the most efficient. Like that just seems like extra work. Like why would I do that? And I get it. I just need to know that you can, so we can move on to the next point. So sometimes things logically don't make sense to do it that way, but just make sure like when you're reading the directions I say to do this, make sure you do it that way. Because even though your way might work, it might not be the stepping stone for getting us to the next step. Like if I said, put it as an object and you just put the calculation. Yeah.
Also, there's like complexity and abstraction. Later on, you can get to writing files that are literally almost 1,000 lines code, and that's not best practice, but they'll get to like hundreds and hundreds of lines, and you'll have multiple files as well. So it's best to organize them and then keep track of where you have everything, and practice good naming convention. And, like say you're only calculating temperature in this. This could be a part of like say a bigger app that you utilize this temperature to, I don't know, predict like future weather patterns into like the upcoming weeks.
Yeah, exactly. Thank you. Yeah, that's why I know like some of the things we do is like basic, like printing it off here, and you're like, yeah, it was easier the other way. Like I don't understand why I created an object and then I have a setter and a getter to change the value when I could have just changed it right in the main method. Like I get like, yeah, exactly. Because you have to think of the bigger picture. Like I might be using this and reusing this or reusing this with working with someone else. It might be part of something else that's bigger. And it's very important that naming, because if your naming doesn't follow the rules, for example, it's frustrating. Again, it's like I like to equate it with like writing a paper for a class and starting sentences with like lowercase letters. Not that people can't read it or they can't figure it out. It's just frustrating because it's like that's just not right? Like when I see an object that starts with a capital letter, it just bothers me because I'm like, this should be a class, or it's just like those things. And I try to get everyone used to like, okay, objects start with a lowercase letter and classes start with a capital. Because when you're looking at the code, it might be tricky, but like, oh, is this a class or an object, or what is this and why is it capitalized? And if you shorten things too much, it's hard to like understand what you're talking about. Like if I, call it calculate, but I don't call it calculate what, then someone has to go search and do more research. Whereas like if you're pretty descriptive and you create like a nice documentation, people don't have to dig into your code and try to figure things out. Because it's pretty easy to just like, oh, this is what it does. And if you don't understand, here's a description. I don't have to go look at the code to figure it out. If other people are doing pieces, you have your own stuff to do and you don't have to go figure out what they did. Like you just want it to work with what you're trying to do. You don't want to have to go examine everything. That takes a long time. So yeah, it's important to follow naming conventions and make sure you have, like I know it takes more work to do like setters, but it's important because if it's private, you can't change it later. And you may not change it in your program, but later down the road, somebody might want to change it. And if you didn't add a setter, nobody can change it. Now you have to go back and add a setter because somebody was like, nah, I don't need a setter. I'm not putting that in there. And it's like, if you think you might want to change it someday, you need that setter. Like, even if you're not doing it, somebody else might do it down the road. Does that make sense? Like, okay. And I know, like, when you look at this, you're like, that's a lot of work for it to do that. And I get it. It's like, yeah, it is. It is kind of a lot of work to add setters and getters. And it looks like a lot, especially with all the documentation. But again, it's good because if you want to, with the documentation, if you want to generate a Java doc, it creates nice documentation for people for later. So now when I look at this, now I have all my methods here. So if I'm confused about, now I know it's pretty self-explanatory, like get Celsius, probably calculate Celsius, right? But I mean, in case you're a little confused, it's right there. And if you're confused about any of the parameters or the return types, everything's in the documentation. And hopefully you don't have to go into the code to figure it out. That's the hopes. If the documentation is good enough, people don't have to go look and thoroughly review your code. Does that make sense to everybody? Does anybody have any questions or is lost about anything? Okay, because we're going to keep doing examples, but I want to make sure that I'm not losing anyone with examples that we've done so far. Okay. Let me see. I know I have another one. I think this one is pretty close to the rectangle one. It should be pretty easy. Hopefully just giving you another example. By the way, all these examples are in your course notes folder on Canvas. So you don't have to type them out or anything. I know they're in the video and you could type them if you want, but they're in the course notes folder. So you could just pull them up. I thought it was a lot of typing to make you type it with me. So I just wanted to go through it, but I hope that that's not taking away from it. Like you could still just go piece by piece. So the circle one just has a radius, which again is private and is a decimal number. And then it does have, and again, you don't need to do this. It does have a constructor that sets the radius at 0, but that's automatic. So you can do it if you want, or you could take that out of there. You will sometimes see people do this, and this is completely fine just to save like on how many lines of code. You'll see them put the curly braces like this together for like an empty constructor, and that's fine if you want to do that. But if that's too much, you can separate them, whatever works for you. It just kind of condenses a bit. So that constructor initializes it, and I don't need to have the radius in there unless you want it, because it's automatically going to do that. Okay. Now this constructor is going to set the radius at whatever you have it, and it's going to go to the set radius method to do that. Okay. So hopefully in the set radius, we have a nice validation, which we just talked about. And so again, the reason for it, and you can ignore that little light bulb because I was talking about the overriding problem that we have, which we don't have right now. So you could just ignore the light bulb. I was telling it to go to set radius, and the reason for that is because again, if you don't tell it to go there or you don't put the validation, then you could get a negative number for the radius when you create the circle. So you need to make sure when we go here that the radius is greater than 0. And if it is, then we're going to go ahead and set it. And if not, then we'll go ahead and set it to 0. Okay. Or we'll leave it. If you did get a valid number in there, it'll leave it at what it was before. So again, having the else is optional depending on your scenario if you want it, because again, this, we'll leave it as what it was before. Now, if you set it If it doesn't have anything, it will initialize it as 0. And if it had something before, it'll leave it at what it was before. So that's okay to not have the else unless you want it there. This will go ahead and return the radius. And then this one will go ahead and do an equation. Now I want to talk about this for a second. So again, this probably not necessary, but I like it. I like it to be action. So like get area. We'll do this equation for you. Now, what is the radius? The radius is my variable that I have up here. So again, that's not something coming in through a parameter. That's the field that I have that goes with the object. And so I don't want a parameter here. I want this to just be the field. And then this, I believe we talked about before for one of our other programs that we had, that math.pi is actually pretty cool because you don't have to remember what pi is. It tells you the 16 to the decimal for it because I can never remember past 3.14. So math is a class that's out there, it's a file. And if you say pi is a constant that's in there and it knows the 16 to the decimal for it. So if you just say math.pi, it pulls that number for you. So you don't have to type 3.14 or go look it up. Because 3.14 is probably accurate enough. But if you put just a couple more decimals, it'd be more accurate. And you probably have to go look it up unless you just know what it is. And you could just type it in there. But I don't bother to memorize it because it just does it for me. So I like it because it'll pull, the number for me. So if you remember that math.pi, and pi is capitalized because it's a constant. It's in this file. Does that make sense to everybody? So this is going to pull what pi is for me and multiply it times the field radius times the field radius. Okay. And then I'm going to do the same thing here. I'm going to call it get diameter. And I should probably change my comments. I do not just like them to be called because then it sounds like a variable. Okay. Your book and I do not always agree. Okay, so this is going to get the diameter. It's just going to take the field radius times 2. And it's going to return a double. Okay. What I get so far? Okay. And then this one, same thing. Get circumference. Okay, it's gonna take this again, it's gonna pull pi because it's gonna be a constant that's in the math file. And it's gonna multiply 2 times whatever pi is times radius and give you circumference. Pretty good. Okay, so you don't have to just have getters and setters of what you have, but you can have extra calculations. And if you don't like your calculation methods to be called get, you can also call them calculate or something like that. You could just call it circumference. I just don't like that it's like not an action word. That was what's bothering me because most methods have action words, but it's up to you. It's fine. Your book does it that way, so it's fine. Okay, so here again we have some extra code in here because we have a scanner, and the scanner is going to ask the user for the radius. Now that is not going to set it at the circle's radius there, not yet. But then I'm going to take the radius in the next line when I create the circle and use it there for creation. So this code so far doesn't change it, but then here, I'm going to use the radius that came from the user who typed in to set that as the circle's radius. Now, the circle's name is called C. Okay, that's the name of the object. And then the radius will be whatever I type in on the keyboard. Does that make sense to everybody? So where is that going to go? Well, let's say I type in 5. The 5 is going to go over here. And remember that when you create an object, automatically the constructor gets called. So if I'm using this, it's going to look for a constructor that matches that. So it's going to look for a circle constructor that matches one argument and one parameter. Okay. So this one doesn't match that, so it's not going to do it. This one does, or no, sorry, this one does. It has one parameter. So it's going to, my number, if I type 5, is going to go into R. And then 5 is going to go here. And then it's going to take 5 and it's going to call the set radius with 5. So it'll go down here and I'll pass 5 to R. And they'll say, is 5 greater than 0? It is. So take that 5 and make it the radius. Okay. So if I don't know why it's upset. Let me go to, oh, because I changed the names. Okay. So this is get area. Get diameter. And this is how your book likes to format. It's completely fine if you like that. It's more like the C++ style. You could do the decimal format. That's what I usually do, but you could do this. This is fine if you like it. So whatever way works for you. If you remember that's good. It's probably a little less work because you don't have to create a decimal format object, but whichever way you want to do it is fine. Okay, so this is going to give it 2 decimal places for each of these. That's what that formatting tells it to do. So well, I could do 5. That's the one I was mentioning. And then I can see what the area, diameter, and circumference for 5 is. And again, each one has 2 decimals because that's what it's telling it to do here with the formatting. Okay, and then just make sure it works. Change it to something with a decimal, and that still works because it's allowing me to do a double. Okay, so this right here is using that constructor. But what if I did create an object without a constructor or without a argument? Well, there's an option for that right here. And so that is going to just make my circle radius. What does it make it? I had it in there before, but I took it out. But yes, 0. And because it automatically makes it 0, that's why I didn't leave the radius equals 0. But if you don't like 0, you can pick a different value and default it in there. Just put radius equals whatever you want it to default to. It'll default there because automatically when you create an object, it automatically calls the constructor. So if you are allowing it to have no arguments, then it'll match this one. And whatever you put in there for the default automatically is going to happen because that's the one that's going to match in that case. So if I leave it alone, it's going to be 0 because that's what it defaults to. So then this should default to 0, and they'll do all of these with a 0. So, oh, actually, never. It's not going to matter what I type in here, is it? Because it's not going in here. So I could type like, doesn't matter. It's going to be 0. Why is it 0? Because nothing's going in here, so it doesn't matter what I do here. It's not connecting it. So the circle is 0 regardless of what I type in there. That makes sense, everybody? Okay, now again, if I want it to be what I type in there, I have to add this back in. And if I don't want them to have a circle without a radius, because I don't know, maybe you don't want to allow them to do that, then I could just take that off of there and just leave the one constructor. You don't have to have that no args constructor. And the good thing about not having it is they have to have a radius when they create a circle. I think if you have a circle, maybe you should have a radius. So that's just my thoughts, but if you want to allow them to, then that's fine. And if I try to leave this off, like maybe I just forgot, then it kind of warns me like, hey, I can't create a circle without a radius. So I'm going to need to put something in there in order for it to be okay. Because if you don't put one, again, you could default it, but you're going to have to go put one later. So especially if you just have one property, especially if it's like a circle and you need to have a radius to do a circle, or if it's a rectangle and you need to have a length and a width, I think that's valid to just not have a default constructor at that point because, but I think for the phone one, it's probably okay to have like a default price or something like that, or, you know, I don't love default constructors though, because again, I wouldn't create a phone that doesn't have a manufacturer model or a price. It doesn't seem like I would have some of those. Like, I think you could leave some of them, but I don't think you want to create an object that doesn't have anything. But you know, depending on your situation, maybe you do. So it is an option, but that's why it doesn't come automatic. Because if it came automatic, then people would be able to create things that didn't have anything. And that's not something we want. Now, if you don't add a constructor, well, then that's what it's going to do. But if you do, then it's like, maybe you don't want people to create that. Maybe that's, and I get it because I don't want that. I think that's probably good to fill in as many things as you can. So, anyone have questions on any of this? Okay. Wait, maybe I don't know if I stopped this. Did I just stop that? I think I did. I don't see the option. Oh no, wait. It looks different.